Okay, in this section we're talking about limits as x approaches infinity. In our last sections we were talking about limits that were going up and down for y being approaching infinity or negative infinity. So we're switching it to x here. These are called limits at infinity. You have your definition at the top. You'll also see, it's also in your textbook of course, you also have your definition of horizontal asymptote here. In the little example I give you on the screen, you have a line here that represents a horizontal asymptote. Now, let me say something different about it for a minute. For this particular graph, here's where x is 3 and 4 and 5 and 6, and x is getting bigger and bigger and bigger and bigger. So for these, we're looking at what happens to this graph as x gets bigger and bigger and bigger. So this particular graph, it's a kind of a rough sketch up here, but this graph is leveling out when y is 3. That means that you have a horizontal asymptote when y is 3. As x gets bigger and bigger and bigger, the graph is getting closer to 3. So one of the things I want to point out is we are looking at when x is approaching infinity. Okay, so that's important. For this whole section, we're going to be looking for where x approaches infinity or negative infinity. The other thing I want to point out from your notes up here that's important is your horizontal asymptote is a y equals equation. Y equals a number. So when you get ready to pick your answers, your multiple choice answers, remember vertical asymptotes are x and horizontal asymptotes are y. Be very careful with the lettering. Okay, in this section we're talking about limits, and we want to deal with these limits as x approaches infinity. There are two ways to do it, an easy way and a hard way. So I have to show you the hard way for proof purposes, but you'll only have to do the easy way on your tests and quizzes and all those things. Now, what you see here is something called cake theory, and if you want to do a YouTube search or Khan Academy search, you can, but here's the principle behind a cake theory. I'm looking at the limit as x approaches infinity of 1 over x. Now, it can be x to the first or x to the second. You just are left over with some x in the bottom. I think of this like there is a cake. I have one birthday cake. Let's say x represents the number of people I invited over. If I had one birthday cake and I invited 3 people over, we'd all get pretty big pieces of cake. And if I invited my whole class over, we'd all get a little cake. But here's what happens here in this type of expression. When x gets bigger and bigger and bigger and bigger and bigger, and you invited 1,000 people to the birthday, you would know that everybody might get crumbs of cake. So in other words, the amount of cake that you get when you're inviting more and more and more and more and more and more people over would eventually get to 0. If you invited 1 million people over to eat cake, you wouldn't get any cake. And so that's what the cake theory says. When you have a limit as x approaches infinity and x is in the bottom, that limit's going to give you 0. Now, that's the theorem behind it. Now, let's actually work one using the cake theory, and then we'll work it the easy way after that. So I ran out of room. Let me write this up here. Try again. So sorry. Okay, what your hard way tells you to do is you're going to divide the numerator and denominator by x to the n. What's special about x to the n is it is the highest power of x that appears in the denominator. So if I look for this particular problem, my highest power of x in the denominator is x squared. So I'm going to divide every term by x squared. Now, each of those 4 fractions is going to simplify a little. So I get 2x over x squared. That would give me an overall result of 2 over x. 5 over x squared would go here. 3 whole number 3, the x's cancel out here, and 1 over x squared. Now remember, x is going to infinity. So if you have an x in the bottom, using my cake theory, if x is going to infinity and you have an x in the bottom, that cake goes to 0. This x is in the bottom, that cake goes to 0. This is the whole number 3. It has to stay. This cake goes to 0. So solving this one out, what you would get is the limit as x goes to infinity. You'd be left with 0 on the top and 3 on the bottom. And 0 over 3 would give you an overall result of 0. Now that's the hard way. That's the proof way. Let's do it the easy way. At the top of the page here, and top of your notes if you want to print these out, you have rules. If the highest power is in the denominator, that means it's in the bottom, then the limit is 0. The horizontal asymptote would be y equals 0. If the highest power is in the top, your answer is either infinity or negative infinity, do more work. And if the highest power is, if they're the same, you put coefficient over coefficient. And eventually you'll also get to asymptotes. Those should be at the end. Let me double check. Yep, they're at the end of this section. So right now I'm only in limits. So here's how they work. In this first one, I have the limit as x approaches infinity. I look at my powers. The higher power is on the bottom. Look at your rules above. If your highest power is in the denominator, then your limit is 0. That's it. All you have to do is memorize your rules. Let me go back a slide. See this one that we worked earlier? Your highest power is in the bottom. If your highest power is in the bottom, your limit is 0. You don't have to go through this fancy proof here. It's just going to be 0. Okay, let's get the rest of these. They should be pretty quick. Okay, for the second one, you have a power of x squared on the top and a power of x squared on the bottom. The powers are the same. If the powers are the same, you have a little rule up there in an orange box. It says, take the coefficient of x squared here, take the coefficient of x squared here, so it would equal 2 over 8, which means your limit would be 1 over 4. These next two, I thought I had miscopied it, but actually they're just so small you can't see it. This one says the limit as x goes to infinity of 2x cubed plus 5 over 3x squared plus 1. And this one says the limit as x goes to negative infinity of 2x cubed plus 5 over 3x squared plus 1. Hopefully you can see it a little bit better that way. Now they are different. One goes to positive infinity and one goes to negative infinity. So what you'll notice about both of these expressions is that your higher power is in the top. Okay, that's my lime green up there. If your higher power is in the top, it's either negative infinity or positive infinity. Do more work. Okay, here's the more work that you need to do. Look at your highest term on the top and look at your highest term on the bottom. Okay, now I know already that my answer is either positive infinity or negative infinity. I have to pick one. Let me rewrite that. Okay, so I know my answer is either positive infinity or negative infinity. I have to pick. So coming to the side, I'm looking for the limit as x approaches infinity, and I'm going to be simplifying 2x cubed over 3x squared. If I simplify that, that gives me the limit as x goes to infinity of 2x over 3. If I plug in a positive number, since I'm going to positive infinity, if I plug in a positive number, 2/3 times a positive number would be a positive result. So that means for this particular problem, I would get a positive result, and the answer here would be positive. Okay, let's do this one over here. So if I look at this one, I'm looking for the limit as x approaches negative infinity, and I'm going to be plugging that in to looking at my higher terms, 2x cubed over 3x squared. If I simplify that out, I'm going to be looking at 2x over 3. If I plug a negative expression in here, 2/3 times a negative number would give me a negative result. That means the answer to this one would be negative infinity. And that's how that one would look. Now I need to make a little bit of room, so I'll go to another video and we'll come back.